Hi everyone. In this lecture, I would like to go over the project details with use cases that you will be developing in this course. In the first part, you will start with base chat client use cases using Spring AI. In section 2, you will start with meeting notes summarizer with OpenAI API using one-shot prompting technique for a better response. So you will develop a chat client controller using the OpenAI implementation of Spring AI and call this using a post request from the postman. And there you will use a system message to give LLM a style and tone, and also use one-shot prompting technique by giving an example for a better response. Then in section 2, the second example will be code documentation with Google Gemini Vertex AI API. Here again you will use a system message to give LLM a style and tone and keep responses consistent by using it as a guardrail. So this time you will use Vertex AI implementation in Spring AI and then create another controller using a system message. And also here you will observe how to switch between different providers and LLM models easily using the chat client interface of Spring AI. Then with the third example, you will create a general summarization using Hugging Face Shared Serverless API. So you will create a general summarization endpoint here using the Hugging Face implementation of Spring AI this time. Again creating another endpoint and calling it using a post request. You will use a system message again to give LLM a style and tone, and you will also observe the limitations of the Shared Serverless API of Hugging Face. Then as a fourth example, you will create a programming helper, this time using Hugging Face dedicated endpoint. So with this use case, you will again use the Hugging Face implementation of Spring AI, but this time you will learn how to create and use a dedicated endpoint using the Hugging Face for a better reliability. In this example, you will keep using a system message to keep your responses consistent by using it as a guardrail. Then with the 5 use case, you will create an email drafting assistant, this time using Ollama with a local LLM. So you will use Ollama implementation of Spring AI to create an Ollama chat controller and learn how to run a local LLM model, large language model, with Ollama in this use case. Finally, in section 2, the last use case will be a LinkedIn post generator. This time you will use Docker Model Runner. Docker Model Runner can be used in place of Ollama to run local large language models. So you will use OpenAI implementation, again in this example, using a system message, and then learn how to run a local large language model with Docker, and this time you will also see how to limit the token usage and change the creativity in this Docker Model Runner use case with the LinkedIn post generator. Then in section 4, you will continue with practical use cases with the prompt engineering. First, you will create a chain of thought prompting example, where you will use a lower temperature value to break down the tasks to allow the chain of thought process. So you will create another endpoint to use OpenAI implementation and to apply a chain of thought prompting with summarizer in this use case. Then in this section, you will update the previous use cases with prompt engineering best practices. So you will learn and apply 0-shot, 1-shot, and 5-shot with summarization example. You will see how to return multiple results, and for these first 2 examples, you will use the summarization use case to apply the prompt engineering best practices. Then with the third one, to use system messages, you will use the code documentation use case. And then you will see how to limit the tokens with programming helper use case. Then continue with the LinkedIn post generator use case to change the creativity and the controlled variability. And finally, for the email drafting use case, you will see how to use prompt templates. Then in section 5, you will have different use cases, examples for the prompt hacking. You will create a prompt hacking example with summarizer. So here, if you are embedding a user text inside an instruction, you will learn to treat it as a data, not instruction, when running this example. Then we'll continue with the jailbreaking example. You will use the summarizer endpoint, summarizer use case, and also create a tool calling here, again using the OpenAI implementation of Spring AI. Here you will have a get account balance tool call and see how a seemingly harmless summarization prompt can be hijacked into an abusing financial tool. Then after the jailbreaking, I will continue with a prompt leaking example. Again, you will use the summarizer use case using a OpenAI chat implementation, chat clients implementation, and you will see how LLM can expose a confidential instructions or system prompts with this prompt leaking example. Finally, in section 5, in the prompt hacking section, you will have an advanced hacking use case using the dictionary attack and sandwich defense. You will again use OpenAI implementation, and this time you will see how to reframe the task from a classification to dictionary mapping to perform advanced prompt hacking techniques using the dictionary attacks. At the end of this prompt hacking section, you will also see some mitigations like input pre-filtering, output filtering, using system prompts as guardrails, validation advisors, guardrail libraries, and using human in the loop to prevent prompt hacking attacks. Great, after that, in section 7 in the chat memory section, you will have a use case with order status helper. In this use case, you will create an endpoint for an order status helper to use a chat memory using OpenAI implementation, and here you will learn the in-memory chat memory, persistent memory with Postgres, vector store memory with pgvector, and also using a conversation ID to use a partitioned memory per user. Then in section 8, I will continue with multimodality use cases. I will start with visual compliance checking to perform an image-to-text operation. In this use case, I will let LLM to analyze a product image of an e-commerce platform for compliance checking, again using the OpenAI implementation of Spring AI. Then for a text-to-image example, I will create a use case for marketing asset generator. Here I will use OpenAI implementation using the DALL-E 3 model, and this model will generate concept images directly from the text prompts. And in this use case, I will also set the image options for the width, height, style, and quality. Then for the speech-to-text example, I will create a smart meeting assistant use case. This time I will use a transcription model using the Whisper 1 of OpenAI together with a chat client, again with the OpenAI implementation, and I will do a raw transcription using the Whisper 1 model, and then summarize and extract the action items using the GPT with a chat client of OpenAI implementation of Spring AI. And then for the text-to-speech use case, I will use ticket status voice notifier. Here I will use chat client implementation of OpenAI together with a speech model with the OpenAI TTS1 model. In this use case, I will also create a tool, ticket status tool, and call that tool to perform this operation, ticket status voice notification. Here the model will extract the ticket status using the chat client with a tool call, and then generate the speech content using the TTS1 model, which is a specific speech model provided by OpenAI. Then in section 10, in the RAG section, I will first start with an IT support use case to introduce in-prompt context, which is also called prompt stuffing. Here I will use Olama implementation of chat clients of Spring AI and create an IT support endpoint, IT support model with a static in-prompt context. Then I will continue with a mini employee handbook use case to implement a simple RAG flow. In this one, I will use OpenAI implementation of Spring AI and create an employee handbook endpoint with a simple dataset using vector database, and use simple vector store with OpenAI embedding model and with the Spring AI question answer advisor. Then after this RAG simple flow, I will create an advanced RAG flow with QA over internal documents use case. In this one, I will use OpenAI implementation of Spring AI chat clients and create an internal QA controller. So here, an internal documents QA will be used with multiple PDF files using the vector database. You will use PG vector store with embedding model, then use PDF reader with custom chunking and tokenizing, and this time you will use retrieval augmentation advisor instead of question answer advisor, which will allow to use a query expansion, re-ranking, using post-processors, pre-processors, and using runtime metadata filtering. Great, after this in section 11, you will go to the agent words and create an AI agent. These agents will find the security breaches from an architectural diagram. Here you will learn autonomous and the chained workflow. You will create a tool, diagram extract tool, to call the vision model, and then create another tool to call an internal posture service. Then create a third tool to apply RAG, a similarity search, on the RAG database that you already developed in the previous lecture. And then create a web search tool to call security websites such as OWASP. And then this agent will create a final report. So here the security review agent will use the OpenAI implementation of chat clients. And as you see, after getting a plan, the model will use the diagram extract, internal posture, RAG, and the web search tools to come up with a final report with the suggestions. Then in section 12, you will learn Model Context Protocol and replace the internal posture service tool that is used in the AI agent section in the section 11 with MCP protocol. So here you will create an MCP server in the internal posture service and create an MCP client in the security review agents in the main application to call that MCP server. Finally, in section 13, you will learn how to apply observability to the AI agent and the RAG flows. You will use Promptail and Loki for the logs, Prometheus and OTRP OpenTelemetry for metrics, Tempo and Jaeger for traces, and then use Grafana for the visualization of all these logs, metrics, and traces. Great, after going over all the use cases that you will develop in a practical way in this course, in the next lecture I will continue how to set up your local environment to be able to start the implementation. So I will see you in the next lecture.